Hi, welcome to the experience machine. This machine is really powerful. It can simulate things that are impossible in the real life and make you feel like you are in it. Now, we take advantage of that to simulate things such as falling into the black hole. But this episode, we're going to look at how we will feel when you are traveling at the speed of light. You have been invited to a light-speed train run test station on the moon. You will be sitting face-to-face with the CEO of the train. It's not awkward. And completing 3 relativity experiments along the way. The train is very good looking. There is a big subscribe to this button on it as decoration, and you walked onto the carpet of the train, find yourself greeted by a charming man, Professor Dr. Job. Oh shit. Job invited you to sit down. He filled the glass of wine on your table. No more words, Steve. Let's start the train. The train starts to accelerate. Strangely, you didn't feel any force pulling up on you, and it's like even more stable than your dad starting his own car. The train is all made out of glass. You can view the entirety of the outside. And the first thing you notice is that your field of view starts expanding. It's like everything has been installed with a wide FOV Minecraft mode. I mean, you can literally see people behind you. It's an undescribable experience. This is because when you're traveling fast, you can literally hit the light coming behind you. And you might have guessed it, when you turn around, your field of view starts contracting because even the light in front of you cannot reach you. The train flashed out of the station. You are now surrounded by the galactic land of star. That is a really bad use of English, by the way. You quickly notice that the star in front of you is blue. As they rush towards you, they start to become more and more yellowish and finally became red sea behind you. And this is caused by the Doppler effect. As you reach a region, the frequency of contact between you and the light emitted by those regions increases, which results in a bluer view. And the opposite is true for redshift. When you move away from something, the frequency of contact between you and the light emitted by those waves decreases, which results in a redder view. If you ask me why is it blue or red, it is because higher wave of frequency emits blue light. That's just how nature works, I guess. Wow, the universe is amazing. Wait, what? How is there so many stars passing by us? Stars are supposed to be light years away. I mean, right now there's like at least 100 stars per second passing by us. How is that possible? Sit down, Steve. That is the effect of special relativity. What is that? When you are traveling fast, the time for the outside speeds up. This is called time dilation. Here's a formula. You can look at it. We are currently traveling at 99.9999% the speed of light, which means 1 second for us is 2.5 days for the Earth. 1 hour is 25 years, by the way, which means in our experience, we are traveling at 200,000 times the speed of light. And this explains why so many stars are passing us by. Wait, what? So my mom is going to die after I return back to Earth? No. She's just going to age 25 years. What? You freak monster! No. I'm just kidding. Your entire family is in hibernation. They'll be asleep for the rest of 25 years. Oh, gosh. You just scared the shit out of me. No. Alright, we are reaching our first experiment station. You suddenly saw 2 lightning strikes the front of the train and the back of the train. Wait, Professor, what is happening? No, calm down. We are doing an experiment. Your train actually passed through a space station. On there is an observer working for Mr. Job. He just summoned 2 lightnings simultaneously. Now, on the center of the train, there is a detector detecting when the lightning happens. And according to the data, there are 7.72 times 10 to the negative 14 seconds of difference between the 2 strikes. But the reality is, they happen simultaneously. The observer also compared the speed of your atomic clock on the train to their clock on the station. And what they found out is that your train is flowing 200,000 times slower compared to their clock. He also compared the length of the train measured back in the moon station, which is 10 meters. But now, it has been contracted to 4.7 times 10 to the negative 5 meters. And all these data are sent back to Mr. Job. I mean, there's gotta be some crazy accurate equipment on the train and the space station to allow for such short and accurate predictions. Wait, Professor, what just happened? What data are you looking at? No, we just passed through a space station. It's too small that you didn't even notice. I mean, we just did several relativity experiments. Einstein was right. What do you mean? The lightning struck simultaneously, but our detector detected a small interval difference between the front strike and the back strike. And this is because we are moving forward, so the light from the front of the strike reaches us first, while the light from the back of the strike reaches us late. And these data proved Einstein's theory that under different reference frame, events are observed differently. Wow, so did they happen simultaneously? I mean, which result is real? Both are real. If you subtract the speed from our data, you would get the exact same result as the observer on the station. I mean, you could say that under a stationary observation system, the both lightning struck together, but under a 99.99999% light speed observation system, there are short intervals between the strikes. Both results are correct. There are no definite true one. Just like you see an apple as red, but a color-blinded person might see it as green. It just doesn't change the color of the apple. Got it, Professor? We also measured the length contraction on the train. It also matched Einstein's result. Length contraction? Yes, the faster something moves, the greater it contracts on the direction of movement. Under our speed, our train was thinner than a hair. Wow, that is so amazing. I mean, Professor, I still have one more question for you. Ask. And this question has stuck inside your head all the way from the beginning. How can we be standing still whilst accelerating, not be crushed into an atom? Well, that's a long story, Steve. Sit down. So you sat down and listened to the professor to talk about his long story. Introducing iSpeed X, our first ever light-speed ship equipped with instantaneous acceleration equipment. It has infinite fuel source and an indestructible ship body. However, recently, many of our customers have died due to great acceleration force. Their bone got crushed onto the back of their seat. Nothing can withstand the force of 30 million G. Introducing iSpeed Plus, our second ever lightspeed ship. It has equipped with light accelerator that only provides 100 G. However, many of our customers complained that it took months for them to reach lightspeed, so this was a big failure. Introducing iSpeed X Plus Max. This ship was revolutionary. It uses our brand new accelerator called Space-Time Accelerator. Instead of pushing ship through the space, it pushes the space through the ship. Thus, no force or no acceleration is experienced by the ship. The ship did not change its position. The position of the universe have changed. This type of ship is called warp drive accelerator. It is the most popular ship right now, starting at 9,999. Wow, this all is amazing. You're such a great entrepreneur, Mr. Job. Thank you. Would you like to buy this ship? I mean, it only starts as 9,900. No, thanks. Alright, no worries. The train has stopped by the moon station. 25 years has passed. Job has led you outside the train. Thank you for taking this ride with me. Now enjoy your trip back home and spend you some times with your family. Hey, Job. Yeah, I still got some questions. What is it? You know, I've been observing the ship. It's not traveling at light speed. It's traveling at 99.9999%. Why not 100%? Why? Is it because we can't do it? No, we can't. It's not because of our technology. It's because of the laws of the universe. When you are moving, your time slows down. When you move at light speed, your time freezes. In contrary, this makes the time of the outside world flows at infinite speed. This means at the instant you enter the speed of light, the universe will die out. Also, when you are moving, your length contracts. Your length becomes zero when you move at the speed of light, which makes you flat and kills you instantaneously. When you are moving, your mass increases. When you move at light speed, your mass becomes infinite, which, according to Newton's second law, makes you unmovable. So, we can't do that. Wait, if you go to the speed of light, your time freezes. Does that mean go beyond the speed of light makes time reverse? No, it's not true. When you go beyond the speed of light, the equation gives you an imaginary time flow speed, which breaks the causality of the universe. It's impossible. Oh, guess I can't time travel then. But why do you want to do it in the first place? I want to save my brother from drowning many years ago. Your tear starts coursing through your eyeball. Hey man, you know, we all have this kind of moment, but you must know that one of the biggest property of life is that we must keep moving forward. We must value right now, this moment, buddy. And there's actually a great YouTube channel called ZZap, which you can search. On there is a video that talks about what will happen if you can reverse your time. You should definitely check that out and subscribe to him. Yeah, Professor, I think I'll probably do that once I get back to Earth. Thank you, Professor. You made my day. No worries. Have a good trip home. Bye, Professor. Bye, Steve. Hey, Steve, wait. What, Professor? A little reminder. Only a small percentage of people that